Particle P is projected from the origin so that it moves in a straight line. At time t seconds after projection, and note that it was projected from the origin, the velocity of the particle is given by this. Show that P first comes to instantaneous rest when t equals 2. So rest means v equals 0. So we have 9t squared minus 63t plus 90 equals 0. That might be quite difficult to factorise, but we've got a bit of a clue that t minus 2 might be one of the factors. So let's see if we can get that to work. So then we'd have 9t take away 45, so that negative 2 times negative 45 gives us the 90 equals 0. Let's just check that that does work. So we'd have negative 45 and then negative 18, which gives us that. And so that's correct. So we get t equals 2, or 9t minus 45, that would give me t equals 5. So the first time is t equals 2. Find the acceleration of p when t is 3.5. So to get acceleration from velocity, we differentiate. So that's going to give me 18t take away 63. The 90, of course, will disappear. And so a of 3.5 is 18 times 3.5 take away 63. And let's just check, it's in meters and seconds, these things. So we have got 18 multiplied by 3.5. And we'll take away 63 from that. And that gives me 0. So 0 meters per second squared. So it's not accelerating at that time. So we now want an expression for the displacement. To get displacement from velocity, we integrate. So displacement is going to be 9t cubed over 3, take away 63t squared over 2, plus 90t plus some constant. Tidy that as much as we can, which is just here really. 3t cubed, take away 63t squared over 2, plus 90t plus a constant. And we know that it started at the origin, so x equals 0 when t equals 0 implies the constant c equals 0. So x is going to be 3t cubed, take away 63t squared over 2, plus 90t. Find. So we now want to find the distance travelled by p in the first 2 seconds. Well, we know the first time it stops is 2. So if we just do x of 0, well, we know that's 0. And if we do x of 2, we know it doesn't turn around in that first 2 seconds. So if we work out x of 2, that will be the distance travelled. So we want to substitute 2 in here. So we've got 3 multiplied by 8. Take away 63 times 2 squared, which is 4. And divide that by 2. And add 90 times 2, which is 180. And that will be 78 meters. So 78 meters for that bit. Now in the first 3 seconds. So we know that it doesn't stop again until t equals 5, but it's going to turn at t equals 2. So having x of 3 would be useful here. Where is it after 3 seconds? So what have we got? We've got 3 multiplied by 3 cubed, which is 27. Take away 63 times 3 squared, divided by 2. Add 90 times 3. And that gives me 67.5. So what must have happened here is it's gone out 78 meters like that, and then it's come back so that the distance here is 67.5. So that would make this 10.5 meters there. So the distance traveled is going to be 78 plus 10.5, which is 88.5 meters.